welcome to the class. So this is ARC 577C/ENS482F. This is what will be the unforgettable non-summer of 2020. This is a virtual course called Digital Artifacts, the Experimental and Practical Applications of Computational Design. And what I'm doing here is I'm going to go throughout the, go through the syllabus, but I'm going to do so in a little bit of a more, I guess, graphically interesting, less text-heavy presentation. But essentially, I'm going to be working my way through the syllabus as per UBC policy. So, the first thing I want to start out with is a little bit of virtual etiquette. And I think it will be good to set these ground rules right now for a few reasons. One, I'm not going to be monitoring the chat, but please do use the chat to sort of text your classmates if you have any questions like someone just had. Is it only my sound that isn't working? Those sort of technical questions I will not be able to help you with real time. There is a TA to be announced in this course, but I've found from other courses that it's kind of tough for a TA to really help people remotely as well. So I'll try to figure out some list of resources to send out. In the last email I sent, there's already a using Collaborate FAQ sheet, I believe. The next thing is if the stream drops, I'll log on as soon as possible. I can't see anything like that happening. My internet connection seems fairly robust, but you know, technology happens, and if that's the case, I'll just log back on. So please just wait. If you have a question, or I guess I'm going to say, please have your audio muted unless you're asking a question. So that's the little microphone icon here. I've been in more than a few conference calls, and I'm sure you all have too, where someone's like multitasking, going for a jog, you know, using an electric blender while attending a meeting, and it is the worst. In my work, there's some guy who just like, I don't know, is paid someone in his family to use the microwave every time he's on a meeting. It's bizarre. So if you do have a question, please click the raise hand button, so this little one here, and please feel free to raise your digital hand at any time, and I'll just sort of call your name for you to speak as soon as possible. So just so we can test that out, since it's been, you know, a couple months since I've used this feature, could someone raise their hand? Awesome. Okay, so in this case I'd say Kevin, I have received your question. I just answered it. June, I received your question, given a satisfactory answer. So that's how we'll do it. So I will get to all questions, but I think it'll just be easier for me to sort of stay on track if I sort of follow that method. Also, please ask me to repeat if needed. Now, this is something where if you think you can wait till I finish my thought, please just raise your hand and then ask me to repeat. But if there's something that, you know, I've just gone too quickly, or if there's a technological problem where my stream cuts out or there's stuttering in the video or something, please feel free to turn on your mic and just let me know, like, hey, stop, repeat that last little bit. Definitely don't mind that, but please just use that if it's sort of as a need-be basis. The last thing I want to mention is everything is recorded and then uploaded to YouTube. So I'll sort of point you to the YouTube link during this presentation. And essentially that means that hopefully you won't have to take very many notes. And if you did miss something in class, my advice to you is honestly to just relax, catch up as much as you can, and then follow up on YouTube. I think that works pretty well for most people I've talked with. So just some of the boilerplate stuff. This class starts today. It technically ends on August 9th, but Wednesday, August 5th is the last class. Monday and Wednesday evenings from 6 p.m. till 8:30. Some classes, I doubt this will ever happen, but we'll see. Who knows, maybe some classes will finish at 8. Regardless, I will stick around for a bit after class online to sort of answer some questions or give some clarifications if need be. This is a 3-credit course. It's online, of course. I'm your instructor, Thomas, and office hours, email me to schedule. And what I am going to do with online help is use a program called TeamViewer if need be. So what that means is I'll be able to remotely access your computer, sort of walk through your Grasshopper file with you if need be. I find a lot of the times email suffices. I'll sort of write some notes in your Grasshopper file and send it back to you. But if you do need to, have office hours, quote unquote, we can definitely figure something out. Have a Google meeting. If anything, I'm more flexible since it's online, so it's good in that way. TA to be announced. Because of COVID, I think UBC is kind of, they have a lot on their plate right now, so I think that the TA sort of, it's somewhere. I think I know who they are, but I don't want to say anything until I've gone to confirmation. That being said, since this is a virtual course, they are more so going to be sort of in an admin kind of role, but I'll talk with them and see what their comfort level is with answering questions, so they may be another resource for you to reach out to. So, a little about me. Like I said, my name's Thomas. I was looking through the class list. I've met some of you, had some of you in my classes before, but I am an intern architect, AIBC, at Pat-Cow Architects. I'm an adjunct professor at UBC, so what I'm doing right now, and I've mostly focused on computational design and digital media. So this is the second time I've given this summer course. This version of the course is much different than the previous version of the course. This version of the course is sort of, I'd say, a nice synthesis of a lot of the different stuff I've taught over the last couple of years. So I think it's going to be a good one. I graduated from UBC in 2016. My professional interests are design optimization and form finding. So something that's quite practical in practice. Voxel-based design, virtual architecture, especially now with COVID, it seems a lot more topical. Site analysis and data processing, which is something that I started out hating and thought was super boring, and now, I don't know, there's some charm about it. And outside of computational design kind of things, I'm really quite interested in architecture and labor issues. And outside of, I guess, architecture teaching work, most of my time, very honestly, goes to these two little dogs. And I put them here, one, because they're very cute, and I hope you think so too, and two, they might bark in the background from time to time, so fair warning if there is any kind of abrupt noise. I'll also add that my home office is adjacent to the building's laundry room, so if anyone decides to throw in like a pair of jeans with, I don't know, some sort of bag of coins in one pocket and the load gets off balance, you might hear some laundry noise, so hopefully not though. So, course description. I'm going to read from the syllabus here. So, Digital Artifacts is a computational design course that will explore the applications and creative misapplications of common digital workflows. So, utilizing the visual programming language Grasshopper, as well as freeware, students will be led through a course-long city-building exercise that begins by sampling real-world conditions and ends with the development of virtual buildings and landscapes. Through this project, students will develop both a directly applicable set of digital skills and a solid foundation in creative computational design. So in other words, I hope that this course helps you get a job, but it inspires you to discover your own idiosyncratic digital techniques. So this course is me trying to sort of balance out two impulses, I guess. One is to have fun and kind of have this unique and kind of experimental summertime course that, is maybe something a little bit different than what you'd be used to during, the fall and winter semesters. But on the other hand, at the end of last summer, I had one student who asked me, okay, some of these techniques were kind of interesting that we learned in class, but how much of this stuff do you use on a day-to-day basis in your real world practice? To which I think I answered something like, maybe about 10%. So in this course, I wanted to figure out how I can maintain that sort of ethos of experimentation while also presenting you guys with something that will actually be directly applicable in the workspace. So the course is roughly divided into 4 topics, which we'll go through. And the real-world utility of these techniques will be fully analyzed, but ultimately deployed in populating the virtual city island of Ananab. And then I reference Borges, because why not? So, in a nutshell, you will gain experience with useful computational digital design tools by developing a building and site for the virtual city of Ananab. I can barely pronounce that, but I'll get better at it. This delivery method will allow us to engage with real-world considerations, so FSR, shadow programming, etc., in a virtual space also allows for expressive freedom and experimentation. So on the right is the City of the Captive Glove by Rem Koolhaas and Madelon Vriesendorp from Delirious, New York. And essentially what we are going to be doing is we're going to be populating an island, and everyone is going to have their own unique building and site based on the lessons we learn in class. So here is the island we will be working on, and you can see what I have done is essentially I took the real world Vancouver GIS data, Vancouver there. I took about a quarter of the downtown core, mostly the West End, mirrored it, mirrored again, giving us both the name of our island and also a nice confined space to work in this course. So essentially all these very practical constraints are going to be applied to the sites, but instead of just sort of everyone working on the same site like we've done in previous courses, I thought we could populate this island. And honestly, I would be lying if I didn't say that my partner's constant playing of Animal Crossing this quarantine has kind of influenced the island aspect of this. Just seeing this self-contained island, in her case of her island of Pachinko, it made me think that would actually be very cool to do in a design course. So hopefully at the end of this course, our island looks at least majestic as this one. Maybe definitely probably has a lot less cute animals living in the city. So like I said, this course is going to be split up into 4 main topics that allow us to build our buildings and our sites. So the first one is sort of starting off with grabbing real world data. So this will be 2 or 3 classes. I say 2 or 3 because I'm not really sure how long this will take. It might take a little bit longer than expected, so I've allowed for a little bit of wiggle room in the first portion of the course. So essentially what we're going to do is we're going to take data from the City of Vancouver Open Data Library. So we'll start doing that today. So for example, we're going to access some LiDAR data. We'll probably do that next class, as well as GIS data. So that's block outlines, building outlines, tree positions, light pole positions, shorelines, etc., in order to make this kind of highly accurate 3D representation of part of the West End. And this will be assignment 1. So assignment 1 will essentially be you taking data from the City of Vancouver Open Data site and creating a sitemap from that. And this first assignment will be worth 20%. So at the end of this assignment, you will have something like this for your portfolio. Now, we won't worry about rendering it from the get-go, but we will be covering the tools later on in the course for you to render this. So if you are wanting to make an AXO like this, you will be able to do so at the end of the course quite easily with the work you've done. So this is kind of a grayscale site model I made when I was sort of testing out the techniques I'm going to show you in this course. So this is from the City of Vancouver. It's this little park over by Trout Lake. And then this is from the last course I taught, ARC 517 by one of your peers, Iris, who did this really nice AXO of Dusty Greenwell Park. So the second thing we're going to do is tower and site massing and optimization. So, you know, this is sort of the arc angles diagram goes here. So 3 or 4 classes, again, it depends on how long we have to put into the City of Vancouver Open Data Catalog. We'll demonstrate parametric techniques to develop a building mass based on shadow envelopes. So that's what we see right here. Site coverage / FSR requirements and programmatic requirements. So in this case, one thing that's actually extremely common in the City of Vancouver is doing these curve shading analyses to create shadowing envelopes. And this is not something that you'll find a Grasshopper plugin for, but it is actually kind of not too hard to do based on some open source data. So we'll definitely be looking at that. In terms of programming, I've sort of, in my research, have stumbled across this great algorithm to sort of use this subtractive voxel method to start to inscribe programs into a predefined mass and to take out mass defined on areas like green space, roofs, etc. So we'll be doing this, which is really interesting. And then the other thing I try to do with this course and the last couple of courses to varying degrees of success is integrate some really useful tools for landscape architects. So in this case, we are going to be spending a class that focuses on the Bison topography editing Grasshopper plugin. And essentially, this will allow us to manipulate mesh. We'll also be looking at a raster-based process for manipulating the ground plane. And hopefully this gives us sort of like a solid foundation for working with landscape in a parametric way. So based on this, we are going to make essentially building masses. Now, I personally haven't made a mass for a while that I can show you guys. A lot of them are sort of like NDA kind of agreements, but essentially we will end up with something like this. That's the last one I made in practice that I can share. You know, all the B-arc angles massing, so it'll be like this, but scattered across, again, where is that? Scattered across this island here. So this thing will be filled with masses. The third part of the course is, so now we have these tower masses, and we need to kind of figure out how to take them from a shape and turn them into an actual building. So essentially, the third part of the course will focus on voxel-based parametric design. So you can think of a voxel as essentially just a 3-dimensional pixel or a cell in a 3-dimensional grid. So essentially what we're going to be doing is we're going to be looking at our masses. We're going to be dividing them up into grids like this. And then we're going to be doing things like taking out spaces for green roofs, for patios, etc., etc. But further than that, we're also going to be doing some other kind of interesting techniques. So the first thing we're going to do is we're going to sort of warm up to the ideas of working in this method using a plugin called Monolith. And this will allow us to do, I'd say, some more aesthetic kind of based stuff. So this is another one of your peers, Stephanie, from last summer's ARC 577 course. This kind of really interesting combination of, we were focusing on cellular automata. So it's a very specific visual language, but I thought this project was quite successful in creating some really neat spaces from the intersections of raster images. Here's a screenshot of Monolith right there. Essentially, you can see it can do pretty complicated stuff, like 3D models of brain scans. So we're going to warm up by working with Monolith. After that, what we're going to do is we're going to subdivide our massings, and then we're going to look at ways in which we can essentially aggregate cells within those massings. So this is another one of your colleagues, Hisuk, also from ARC 577 last year. So in this project, she aggregated these cells like so across this mass to create a really interesting shape. So we're going to be building off of this, except what we're going to do is we're going to be taking the raster intersection of Monolith, combining it with the cell distribution of, in this case, it was using the plugin WASP, and we're going to use it to array certain kind of cells within a mass. So this is a quick little diagram I whipped up. You can imagine if this is our mass as developed in part 2. We subdivide it into voxels based on program. So red, let's say, equals solid space, green equals open space, blue equals windowed space, and then you can see we assign those programs there. So from that point, we will end up with our finished towers. Now, the reason why I chose all these slides is that there is a certain design language that is sort of formed around voxel-based design. So that's guys like Guy Retzen, Manuel Jimenez, and they definitely have very specific design languages. But what I wanted to show with this slide was that even though we will be focusing on distributing program in our masses in a very specific way, the formal opportunities are going to be quite open. So I'm definitely not going to prescribe an aesthetic. I have been loving Ricardo Bofill lately, so this is Walden 7. It is formally modular, but structurally not so. So I want to emphasize that we're not going to be, unless you want to, you know, your building doesn't have to look like Habitat 67, Moshe Safdie. Sajima's Nishinomiyama house in Kyoto, so you could do something that's a little bit simpler, quite elegant. If you look at even this flowing Zaha Hadid, the Jockey Club Innovation Tower in China, you know, these are repetitive pieces kind of slung around a flowing form. So you absolutely could do something like this. A very extreme contemporary example is Mark Foster Gage's Guggenheim Helsinki competition entry. If you want to do something as wild as this, you know, you are more than allowed to. I'd love to see a project like this. And even, you know, looking back historically, this is the Meenakshi Temple. I won't pretend to know much about it, rather than I was just trying to find historical examples of repetitive architectural elements, and this was really quite striking. So this was in India, and it was built around, I think, the 1st century CE. So absolutely stunning piece of architecture. So the kind of direction you take from an aesthetic point of view, there is no direction. So we're really just going to be focusing on this one particular process, though. So the last thing we're going to cover is virtual representation. And essentially, we'll focus on creating virtual representations of the buildings and sites developed in previous 2 topics. So you will be taking through the process of translating Rhino geometry to Unreal Engine using the DataSmith pipeline. Basic texturing and rendering will be covered. So in the last course I taught, so that's ARC 517, this is one of your colleagues, Aiden. His images here, really, really nice images. They look, quite realistic. And this was done using Enscape. And I was extremely happy with Enscape, but unfortunately it seemed about a third of the students in the class, their computers were not happy with Enscape. So what I did after that course was I got a few students who weren't able to use Enscape, and they were kind enough to test out Unreal, and Unreal worked for everyone. So I do think that virtual representation is definitely a useful thing in a course like this, because it allows you to sort of present your projects in your portfolio right away. That's what I want you to get out of this course, sort of like something that's ready for your portfolio right off the end of the, right at the end of the course. So a few reasons why I chose Unreal, because it might seem like kind of a strange choice, maybe at first glance. So it's free. Unlike Enscape, it's free for, as long as they decide to make it free. It seems for the foreseeable future it'll be free. It works with all systems. I really don't want to spend a ton of time troubleshooting, so at least I think now 6 computers with very different hardware setups that we've tested on all works. It's a bit more complicated than Enscape, but also leaves a lot of room to play around with. And this is a huge thing in this course. You can take advantage of Rhino blocks, aka voxels. And what I mean by that is that if you have one unit like this that is repeated, 120 times, Enscape will only, we'll go back to this, or Unreal will only have to store the information of this one voxel or block once, and then it uses some fancy algorithm to distribute it. So you'll find that working through this methodology, your buildings actually will render quickly, and you'll be able to do walkthroughs very quickly. So it just seemed like a good fit. So we'll be spending about 2 classes on that, maybe 1.5. It's not the primary focus of the course, but I think it's kind of like a nice little change of pace at the end. And then you can create walkthroughs, also standalone programs. And if architecture is not working out for you, you can make a move to the video game industry. The other thing on, I guess, the final note of video games, one thing that I would really like to do, and I'm trying to get this work, but we'll see, but, fingers crossed. My idea is that our final presentation takes place online in a model that we can all fly around in. That is my dream. I'm working on it. There's been a few hiccups, but hopefully it works. So worst comes worst, if we're unable to do that, everyone will still present their model in a fly-through manner. It just won't be all online at once. So, but it'll still be great. So does anyone have any questions about all of that before I switch to the syllabus proper? Okay, great. So I'm just going to switch to the syllabus proper, so I don't have nice graphics about this, but I still have to go through this. For the opening of this course, I did want to do a territory acknowledgement. So this course takes place on occupied, ancestral, and unceded territory of the Musqueam, Squamish, and Tsleil-Waututh people. And I think it would be worth reading through this little section here. Why do we include this acknowledgement? And essentially, in a nutshell, even the city of Vancouver, who, mixed opinions on the way that they have dealt with First Nations issues in the past, even the city of Vancouver fully admits that it is occupying stolen land. So I figure if a giant bureaucratic corporation admits that, I think that our course should too. please go through the these few links here that have some good background information on that. I think as I put here, as design practitioners operating in Vancouver, this is something that you need to really be keenly aware of. So the class delivery and structure. So these are where I include some specific tips for using Collaborate Ultra. If you're watching me right now, for the most part, it seems like everything's going okay, but there are some more tips there. You can access, or ARC 577C students can access the online lectures through their UBC Canvas accounts. I'm sorry, N students, just because there's less of you, I can't add it to Canvas for you. I can't merge the two courses together. If anyone knows how, let me know. But you can always join with this link here. First of all, can someone raise their hand or say okay if they are an N student? I just want to make sure that... okay, thank you so much. Thank you. Perfect. So the N's cohort is here, so that's good. I'm glad you made it. So again, my apologies, but this link will always work. The class will take the form to a 2 to 2.5 hour lecture. Please raise a hand at any time. So course material will be accessible via the class Dropbox. If you haven't done so, please fill out this list. And essentially it's just going to look like this. So feel free to fill it out right now even. And essentially, I know that you can share stuff over Collaborate, but I'm not sure how robust it is for sharing like Rhino files. So Dropbox just works. You don't have to download it to your computer if you don't want to take up space. Just I'll invite you, don't sync it with your local Dropbox, and then just download the files when you need. And also all lectures will be recorded and accessible online at my YouTube page, which is again kind of weird that I have a YouTube channel. But essentially, if you want to follow that link, all the videos will be uploaded here. And if you look on my account, you can actually check out previous courses videos if you so wish. So evaluation general, you'll be graded on 3 criteria. So complexity of ideas, depth of analysis, quality of production, participation, and work habits and progress. So this second point used to say participation and attendance. I'm not taking attendance because it's online, and I mean, like, you know, you can just minimize the window, so it doesn't really matter. That being said, I would encourage you to show up on the given times. Not only will it bring some structure to all of our, you know, pajama-wearing quarantine lives, it will also sort of give you the best learning experience, so you can ask questions and whatnot. All 3 projects, their rubrics begin with the same baseline, so just begin. Students will be evaluated and graded on 3 criteria in no order. So synthesis and reinterpretation of lecture topics and techniques, clarity of annotation and organization. Whenever I'm getting into Grasshopper, I'll show you what I mean by this. For those of you who've taken a course with me before, you will know my use of panels. So the question here, anyone know how to get access to the syllabus / Dropbox? The syllabus I emailed out. The Dropbox I will be inviting you to after this course. I haven't sent out an invite for the Dropbox. I wanted to make sure most people were on the list before I did it, so I could do it in one big chunk. So expect that tonight, tomorrow at the latest. I'll resend out the syllabus tonight just in case you missed it. So in addition to the above criteria, extra marks will be given to projects that demonstrate technical exploration, definition, iteration, concepts not covered in lectures. So essentially, if you really try to expand, you show initiative and demonstrate that you're trying to self-learn, I absolutely would love to give you some extra marks for that. And further clarification of what is to be expected will be defined on a project-by-project basis on the project sheet, the first project brief will be handed out on Wednesday. Late work, so 5% per day penalty. This course has been sort of set up where I hope that you can work on your projects kind of as I present in class. So what I'm working on in class is kind of directly how you would do your project, especially for assignment 1. You can really just follow along in class and have your project done. So please try to get your stuff in on time. Not only will it give you the highest mark possible, also makes it easier for me. So assignment 1, the site modeling exercise is worth 20%. Assignment 2, the massing is worth 30%. And assignment 3, the kind of fully textured virtual walkthrough of your tower is 50%. UBC policy dictates that your courses are graded on a certain scale, so refer to that. Additional needs, if you do have additional needs and need to send me the special considerations form, please do so. Just let me know also if you're sick, especially in the age of a pandemic. You know, I'm fully aware that people get sick. So if you are going to be late, please let me know, or, you know, hand in an assignment late or something's holding you back, just let me know. So software, you'll need the following software. So the first one, Windows. And I'm sorry, I've tried over and over to make this course work for Mac users, but there's always so much troubleshooting to be done, and it does seem to slow down a lot of students. And it seems that the majority of those students end up installing Windows anyways. So to save you a lot of hassle right now, please just install Windows as soon as you can. So Boot Camp seems to work better and is free, but Parallels does seem to work. So, you know, whatever you want to do. And I've just found that the Rhino and Grasshopper plugins are kind of unreliable. And if you're taking Roy's course, there's no Revit for iOS, and 99% of offices use Windows. So, I mean, c'est la vie. So you can get a workable copy of Windows for free and use Boot Camp for free. Follow this link. So don't want to, get you to spend extra money. You don't need to. And you can also download a free demo of Rhino 6. So right there, if you don't have it, you can use Rhino 5 if you're taking this course. Hopefully there's no troubleshooting to do. If there is, please let me know and I'll try to help you through that. But please install Grasshopper Python as soon as you can. So the link's right there. So the other thing I want to say is please have the software installed before the beginning of class. First class excluded. We'll go through some things this class. And what I'm referring to there is on the schedule right here. You'll see on the right-hand side of the schedule, I've put the plugins. And you can click on those links or just copy them into your web browser and you'll be able to download them. So some of these programs are not Grasshopper plugins like one we use today. And these programs are all free. They're all extremely useful tools. Feel free to delete them after the course, but this is sort of the workflow I've developed over my years of doing this kind of stuff. And I've always sort of stuck to the motto, like, if it's free, it's, better. So you won't have to pay any extra money for that. I'm pretty conscious of all that stuff. The next thing I want to say is software skills prerequisites. This was kind of, I think, a curveball for a lot of people last summer. And also I noticed that some people, unfortunately, dropped the course. It might be for other reasons after I sort of announced this earlier, I think this month, via email. But basic Rhino and Grasshopper skills are necessary. So this isn't an intro to Rhino and Grasshopper course. However, I will say the skill bar is, it's pretty low. This course is more about workflows, I'd say, and it's not about like very much getting into the deep recesses of, computational design. Like, we're not going to be scripting anything like that. You will learn grasshopper skills, that is for sure. You will learn new techniques. You will learn new terms and, all that good stuff. But ultimately, it's not that advanced. So I don't want to intimidate. If you've taken a DM2 course within the last 2 or I'll even say 3 years, and you at least remember the basics of how Grasshopper works, and you feel free, or you feel confident that you could, maybe use Grasshopper to do a rectangular array or something, you'll be A-okay. If you're really unsure, reach out to me. That being said, if you currently don't feel comfortable with Rhino and or Grasshopper, but this course seems really interesting to you and you still want to take it, please do. Just spend a little bit extra time. And I think about 3 to 5 evenings of self-learning plus this course, you'll be able to sort of gain a really good foundation in Rhino and Grasshopper. So in the Dropbox folder, I sent this out in an email earlier this summer. In the Dropbox folder, which you'll all have access to shortly, you'll see there's a self-learning resources text file, and it just has some sort of, some guidelines for how you can gauge your level of skill in Grasshopper and Rhino, but also how you can catch up on those. Again, if you don't, feel free to let me know if you have any concerns or if you want more resources. I feel that anyone can take this course. It's just you do have to be aware that you might need to catch up a little bit if you've, never opened Grasshopper. I won't go through this in much depth just because a lot of it's going to kind of covered and maybe won't make sense. We'll refer back to it later. But essentially, like I said, for the first 3 classes, 2 to 3, we're going to be working with the digital site model. So you can see I have a tying up loose ends class here at the end of the second part, the massing part. If we need 3 classes, this class will be removed. That's fine. So after the digital site model, we'll start into the massing. Assignment 1 is due in about, 2.5 weeks from now. But like I said, we'll be covering everything in class. Canada Day falls within this course. BC Day also falls within this course. We have 1 less class than usual, unfortunately. But that's okay. If we do make it through the digital site modeling quite quickly, we can do a bonus lecture on some other kind of massing analyses. So maybe a privacy or view analysis. We can do a class poll. Who knows? So after that, the voxel-based parametric design will be working with monolith, then working with the programmatic intersections. The one thing that's worth pointing out in this section is that if we look at, this kind of building, you can imagine even though there are repeated elements here, there's more than one repeated element. And, it might take quite a while to model all the repeated elements necessary to make, Ricardo Bofil's Walden 7. So as a result, what we're going to do is we're going to break out into groups. And as teams, you're going to sort of come up with a language. So this way, essentially what's going to happen is neighborhoods within the island city might have different characters. So there's going to be a little bit of group work, and Collaborate Ultra allows for breakout groups. So that'll be good. Finally, we'll end with sort of introduction to Unreal, basic materials in Unreal, basic renders and walkthroughs with Unreal. And then we have a work class. BC Day, no class. Now, this might change, but right now I'm saying assignment 3 is due on Monday, August 3rd, so before the last class at 6 a.m. And that allows me to hopefully compile the entire island with all your projects so we can all fly around it in virtual space at once. If that changes, I'll let you know. But right now it's sort of, that's kind of what I'm thinking. So that is the syllabus. Before we dive into the course, is there any questions from anyone about anything. Are my sound levels okay? I see my mic, it looks like it's maxing out. Is it breaking up or is it okay? Good. Okay, great. It's such a weird feeling teaching online. It makes you feel a little bit like you're just like talking to yourself. So thank you for the feedback. Okay, so what I want to do is essentially a la a old school Julia Child cooking show. We'll say, voila, this is what we get at the end of this class. So this is what we're going to be working towards in this class. So in this class, essentially, we're going to look at importing data from the city of Vancouver. So we're going to look at importing what are called ortho images. So essentially, these are just super high resolution images that are corrected for perspective, kind of like Google Street View. So how do we import them using the GeoTIFF plugin, the freeware, as well as how do we import in all of the road data from the city of Vancouver, all the block outlines from the city of Vancouver, as well as we will dive into using basic Grasshopper to extrude buildings based on the footprints. And as I say all that, I'm thinking we probably won't get through it all, but like I said, we have an extra class for this kind of stuff, so that's good. Next class, we'll be working with the LiDAR data to make kind of the 3D topo that will go underneath this. So all these buildings are floating, they're floating at the proper height, but it's next class that we actually make the ground. So I'm going to close Rhino. And what I am going to do is we're just going to start by downloading some stuff. So I'm going to open my web browser of choice. And essentially what I want you to do is essentially, I have the URL here. I'm going to copy the Extensis GeoViewer URL into the chat. So you can click that URL. And some of you might have installed this already, but essentially, since this is the first class, I just want to make sure that we, all are on the same page. So you can install it, save file. The other thing we're going to do is we can go to the @it for Grasshopper. So this is Grasshopper plugin. So while that's downloading, I will copy the other plugin in the folder. So @it, we can just open another tab here, copy that in, and this is @it. Now, one thing I didn't really think about, to be honest, is that you need to sign up for Food for Rhino. That's okay. What I'm going to do in the meantime is I'm going to save this file and I'll throw it in the chat. So I believe I can share files. Let's see. Share content. Share files. Okay, so I'm going to put this. Oh. Okay, I'm going to copy a link for a download for this. Sorry about that. I thought I'd gone through all the little quirks that could come by having an online course, but that's okay. Okay, so get a link. Yeah, add your files. Okay. Okay. Great. So I'm just going to copy this link and I will share it to the chat. So in the future, what I will do is if anything like this happens, I'll also save these files in the Dropbox just in case. That being said, like I mentioned, please come to class with these files already, or these programs already installed, so we don't have to do this in class. First class, it's okay. What I did want to point out, though, is this website, Food for Rhino. If you're working through Rhino or Grasshopper, it's going to be your best pal. You can get all sorts of cool plugins from it. In this case, @it is going to be the way that we read certain GIS data formats from the City of Vancouver Open Data. So GeoViewer support, all I want to say here is that if you can't figure out how to do something in Rhino, look it up online. There's a good chance there's a free program that does that. So I'll just go through the setup. I think for the most part, it's going to be fine. The one thing I did want to point out is this Slim DX or whatever. I noticed that before it said it had an error and it couldn't install it. So if yours also has an error and it can't install Slim DX, don't worry about it. So yeah. And I've already installed it, so just follow that same setup. So now I want to show you a little tip for installing a Grasshopper plugin. Just because I kind of discovered it, it's one of those things where I just realized, like, I am dumb. Why did I not realize this years earlier? But a lot of you will have a problem where you try installing a Grasshopper plugin, but you can't because it's blocked. What I've realized is before you unzip a file, you can right-click the zipped file, go to Properties, go to Properties, click on Unblock on the zipped file. So right-click the zipped file, go to Properties, click on Unblock next to where it says this file came from another computer and might be blocked to help protect this computer. Click OK. Once you've right-clicked it and clicked Unblock, right-click it again, extract all, extract it to whatever folder. So this is the extracted @it. And now all of these different files in here, they're unblocked. And the reason why I want to point that out is in the past, I've always decompressed a file and then went to unblock. But what that means is you would have to go through all of these DLL files and unblock them one at a time, which would be the worst. So that was just a little bit of a, an illuminating moment for me. So that's why I wanted to share it. So how you install a Grasshopper plugin is just open Rhino, go to your standard tab here, click the button, or if you're in Rhino 5 or can't find that button, type Grasshopper. Go to, so your Grasshopper screen is opened. Go to File, Special Folders, Components folder. And then you're going to want to copy in the @it folder. So you can see I already have it there, but if you didn't, or if I didn't, I would just go to that, the folder which has all this stuff in here. So the @it folder, copy, and then I'd paste into my libraries folder, like so. I'd close that window, and then I'd just close Grasshopper. I would close Rhino, and the next time I open Rhino, it would be all good to go. So let's reopen Rhino. So we're going to start with a blank screen. So at this point, you should have had two programs installed. So the first one is the GeoViewer app. And then the second one is the @it plugin for Rhino/Grasshopper. So those are the two plugins we're going to be using for this class. So the first place we're going to go is the sort of the promised land of all urban data about the city of Vancouver. We're going to go to opendata.vancouver.ca. So look in the chat, I have just pasted a link right there. Now, they've revised this data set, this catalog, since maybe my last class looked at it. So it's actually been quite recently that they've sort of upgraded its interface. So it works more or less the same, though. There will be some changes. Another thing, actually, that I forgot to mention for my previous ARC 517 class, if you're thinking, oh man, this is the same thing we did at the beginning of last class, things have changed. Meerkat no longer works, so you have to relearn a new method like I did as well. So, so this will be all new stuff for everyone. So in here, we're going to start accessing some different kind of data to bring into Rhino. So what we can do is we can go to Catalog in the upper left-hand corner, and it's going to bring up a screen like this. Now, there's lots of ways you can filter. You can just always search for something. You can go down and look at the themes, keywords, etc., etc. There's also a map view, all these things. But anyways, what I'm going to do is we're going to sort of go by theme here. So the first one we're going to do, I'm going to click on More, and I'm going to click on Streets and Transportation. And essentially what I'm going to do is I'm just going to open my City of Vancouver lecture file to show you what we're getting. So the first thing we're going to want to do is we're going to want to grab some roads, some alleys, these pink lines. I believe blocks are in this package as well. And we just sort of want to grab all the things that we can start to use to create our site model / really nice site drawing. So the first thing we're going to download is public streets. So why don't we scroll down, find public streets. You could also search for it, or you could in your browser, Control F, look up public until you find what you want. So public streets, let's click on that. Now, there's a few different ways that we can access data. If you click on the Export tab first, we are going to use the DWG. So if you look through these formats here, there might be some that are familiar to you, some that aren't. You might be thinking Excel. That's strange that we can export this data as Excel. But one thing that we know for sure that you're probably familiar with is DWG, so an old trusty AutoCAD file. So we're going to use this. Now, do not click on download yet. One thing that we have to remember to do, and please burn this into your memory when working with Rhino and GIS data, is we need to talk about our projection. So you can see at the top here it says export geographical coordinates as, and then this has WGS84. And I think this stands for, I'm going to make something up, I don't know, World Global System Developed 84. We don't like this one. It's a projection that doesn't work for Rhino. The second one, though, EPSG 26910, this does work for Rhino. And one thing that I do remember about the WGS84 from the GIS course I took 10 years ago, 12 years ago, is that this coordinate system, this projection, is meant for very large areas, whereas the EPSG ones are more localized. So I believe this is localized for actually regions in the West Coast. So long story short, City of Vancouver Open Data, you're always going to choose EPSG 26910. So always choose the second one. So we're going to make sure EPSG 26910, and then we're going to click download. And then we're going to save. And it should save right there. Now, I'm going to talk about folder organization. I know it's not like the most intriguing topic, but I think it's one kind of worth doing. Essentially what I'm going to do in maybe just my downloads folder for now is I'm going to make a few different folders, because you'll find that you get a lot of data quickly and you want to make sure you know where it is, especially if you're working in a firm and you need to quickly parse out the data. This is key to start your file structure first. So why don't we just create a new folder? We'll just create 3 basic ones for right now. We will go vector. Vector referring to any kind of DWG road drawing. We'll make a new folder called point cloud. This will refer to any 3-dimensional LiDAR data. So we'll be dealing with that next class. Let's right click again, go to folder, and then let's go to raster. So raster is going to be those ortho image files. So these ones right here. So public streets is vector. So let's just drag it into vector. So vector, point cloud, raster. So that's good. Now, why don't we just click back a couple times to go back to the main the main streets and transportation section. So we've downloaded that data in one way. We've downloaded it in a DWG format. So now let's go new. Well, you can probably have a new file, but let's all go file new. And the reason why, even if your screen's blank, I want you to go file new is because we want to choose the large objects meters format. Or a template, because all the City of Vancouver data and most GIS data is in meters. So at least this side of the American-Canadian border. So large objects meters. If you do not get that screen and you're not sure where your units are, units in Rhino are file, properties, units, and then make sure they're meters. Now, once we have our Rhino file open, or our blank file open, why don't we just save it right now? It's good to save often. So I'll just save on my desktop. I'll save it with today's date, however you like saving your files, and I'll call this COV import, and I'll continue to work with this next class. So I'm going to save it, and that is good. So what we're going to do now is we're going to import those City of Vancouver roads, and since they're a DWG, it should be fairly straightforward. So let's go to File, Import. Let's go to our downloads, or maybe you move that file elsewhere. Vector, and then public streets. Again, click open. Now we have this DWG, DXF import options that come up. We are going to uncheck all of these. So import unreferenced layers, import unreferenced blocks, import unreferenced line types. We're going to uncheck them. Convert wide polylines to surfaces, unchecked. Ignore thickness, unchecked. Convert regions to curves, unchecked. Mesh precision, automatic. And then here, just make sure that your model units are meters, and then your layout units doesn't really matter because I don't think there's any sheets in the City of Vancouver file. So just make sure model units equal meters. And set layer material to layer color. Don't worry about that. And then I like to leave this unchecked because I like having this dialog box. Click OK. Great. Now we see nothing. Now, if you go to your layers, you can see there is public street. So what I'm going to do is I'm going to right click on my layers. So if you don't see the layers panel, again, you can click the little cog there and make sure the layers panel is on. So once you have that on, you're going to see that you have a public streets layer. And this has been brought in from that DWG file. So I'm going to right click the public streets layer. I'm going to go to select objects. And you can see now it says one block instance, 17,030 curves added to selection. So we did import it even though it didn't show up. The reason why it didn't show up is right now we're at the origin, so 0, 0, 0, 0, and our import is way out from the origin. So that's fine. So once we know that, you could either, scroll in to zoom this, or else you could just go Control-Alt-E to zoom extents. So again, that's Control-Alt-E, or you could go to View, Zoom, and then selected all. Now, the reason why this comes in so far from the origin is because this is GIS data and it's positional data. So it's based on real world coordinates. The origin for this particular projection, so that's the EPSG 26910 or whatever it's called, its origin is, I don't know, somewhere in Seattle or something, far away from Vancouver. So as a result, all the Vancouver data is going to be brought in relation to 0 that's all the way over there. That's fine. Do not move your GIS data to the origin until you're absolutely sure that you're done importing layers. A lot of times I like having a quote-unquote import file where I will import data and then I can move it to the origin later if need be, but just be aware that that's the reason why this data is so far out. The project I'm working on in the office right now, between the Revit file, one of our consultants' AutoCAD file, the Rhino file, I'm not going to lie, it sort of sucks to keep having to transfer the origins. We've automated a little bit, but it's just something, you got to do. You want to keep everything exact as possible. Another reason why I thought it'd be cool to move into a virtual island space where we don't have to deal with translating the origin all the time. So that is public streets. The next thing we're going to do is lanes. So let's open back up our City of Vancouver. We can scroll down till we find lanes. Lanes, there we are. And then let's go to export, and then lanes.dwg. Again, make sure export geographical coordinates as EPSG 26910. Always choose that one. So alternate exports, lanes.dwg, save file. I will open the folder, and I will copy lanes into vector just to keep it nice and organized. Now this will be a little bit of review, so we can do the same process in Rhino where we import the lanes. So now let's go to File, Import, choose Lanes, click Open. Now I'm unchecking this stuff and I'm clicking OK. So now you can see the lanes have been brought into the exact precise location we want them in, because everything is referenced to the origin, which is way over, in Seattle or wherever. Now, to differentiate between lanes and public streets, what we can do is we can change the color of our layer. So lanes, we can double click on the red rectangle, and let's change it to, a pink or something. So now you can see if we look in the top view, we have lanes, and we have public streets of all of Vancouver. So we're going to do this kind of process for a few other data sets. So if you fall behind in this, because I'm going to move a little bit faster, don't worry. Just make sure to go back and import them. But the other two categories that we're going to import in the same way, actually, I guess we'll just do one. Let's do block outlines. So let's go back to our browser. Let's click back so we're in the main location. And let's find block outlines. Again, you can just click Control F to search for block. Okay, so if it might be in another section, that's okay. If you want to find something that's elsewhere, maybe just, so what I did was I clicked on the catalog. I'm just going to search in the entire data set. I'm going to search block. And we can go block outlines right there. So again, what I did was I clicked on catalog in the upper left-hand corner, and in the filters, I typed block. Hit enter, and then block outlines is partway down the screen. Here, I'll copy block outlines just in case someone didn't find them. So that's in the chat. So this is going to be the same idea, export, and then we can just go to blockoutlines.dwg.zip. So let's go to EPSG, go to download, save file. So it looks like this one's going to take a little bit longer. So let's start downloading the next one. So let's click on catalog again. So the final one we're going to search for is the building footprints. So we can just type in footprints. So we're looking for building footprints 2009. I'll copy building footprints 2009 to the chat as well, just in case you can't find it. And essentially we're going to go to export. We're going to make sure we choose EPSG 26910. And then we're going to go to building footprints 2009.dwg and download and save file. Great. Perfect. So what you should have is building footprints 2009 and then block outlines DWG, but this is a zip file. So again, like any zip file, you might want to right click it, go to properties, click unblock, click OK. That just prevents you from having to unblock it after you unzip it. I'm going to right click, go extract all, click extract, and there's only one file in here, so I'll find that file in the extracted. I'll just cut the block outlines, go back into my main folder, copy it into vector, and delete those extra folders there. And I'm going to select the building footprints, and I'm going to cut it into my vector folder as well. All right, so in your vector folder now, you should have block outlines, building footprints, lanes, and public streets, which we have already imported into Rhino. So what we can do now is we can just import these in the same manner. So file, import, block outlines, open, these are unchecked, all units, meters, all good. There are the block outlines. We can change their color, let's say cyan in this case. And let's also import the, so file, import the building footprints 2009. So these can be our building footprints. So let's go mall units, meters. Yeah, so that's all good. All right, so this is all of Vancouver. You can see it's a lot of stuff. What we're going to do is now we're going to delete everything that we can outside of the section we need. And this sort of, ends the point of this demonstration where we're using DWG imports, and the reason why you'll see that we stop using it is because it gives you a little bit more control over what we import. But you can see that DWG import from the city of Vancouver does work, especially for 2D data, but it's just you probably want to delete some of the extra stuff afterwards. So probably the easiest way to do that is to type lasso, so L-A-S-S-O. I'm not sure if it works for Rhino 5, to be honest. If it doesn't work for Rhino 5, what you're going to want to do is just, select something like that. But I like using lasso. And I'm just going to select around downtown Vancouver, like so. And after that, enter. Now what I'm going to do here is I'm going to go to Edit, Select Objects, and then Invert. So Edit, Select Objects, Invert. So now I've selected everything, and I'm just going to delete it. So now what we're left with is a much more manageable chunk of Vancouver. So that's still a ton of data. You can see there's some fills here, but that's good. One thing we might want to do is get rid of these fills, just because they're, kind of random fills that we don't want to format later. We can also at this point just go Edit, Select Objects, and then we could go to Hatches, and then hit Delete. The final thing we want to do here is change our Vancouver footprints. Let's change the name of this layer to Vancouver Footprints 2D, because we are going to import the footprints again in a different data format. And that's just because I want to show you the, multiple ways of doing this. But the second format, the shapefile, is going to allow us to create 3D buildings out of this data. Another thing we can do now is just delete all these extra default layers. And I'm going to save. So does anyone have any questions? I think it's a good moment to ask. Okay, excellent. I will take that as everyone's sort of sticking with me, so that's great. So the next thing we're going to do is we're going to import the building footprints again. Except what we're going to do is we are going to import them in a different way. So we're going to import them as a shapefile. And a shapefile is a GIS format. So GIS is just a global information system format, I believe. It's essentially what a lot of city planners use to create maps and geographers. So it does work with Rhino, but you do need a plugin. So that's why we installed that @it Grasshopper plugin. So what we're going to do is we're going to go back to our City of Vancouver data set, and we're going to go back to the Building Footprints 2009 section. Again, the link for this is the last comment in the comments, so click there if you close this window. And then what we're going to do is we're going to look at the shapefile, right? So it says shapefile, can't download it, and it says this export format is limited to 50,000 records. So you can download a smaller part of it by filtering it. So this is great because we already saw from importing in the DWG we have no choice in what we import. If we work with shapefiles, we can import smaller chunks. So let's go back to here. Now let's click on the map. So Building Footprints 2009, click on the map. So now what you can see is if you zoom in on the map, you can see that we have the building footprints. You can see the shapes displayed on top of the map. Oh, thank you everyone in the comments for sort of group helping. That's actually perfect. Yes, thank you, Ranveer. so Ranveer's last comment, so go to edit, select invert, using the little arrows like that is just like perfect helping, I think, format. So if someone asks a question and the group can answer like that, that's great. Ellen's also is, and Nora, yeah, so great. So anyways, we are on the map here, and what we can do now is we can essentially select a portion that we want to download. So we don't have to select the entire city. So what we're going to do is we're going to select the little polygon tool right here. So if you look in the upper left hand corner of this Google Maps or Open Map window, we can select the polygon. And what we're going to do is we're going to select a portion, like so. Now you might select a little bit less. It doesn't really matter. I'm not going to be, for assignment 1, I'm not really going to be marking, the extent of what you do. Please don't select just like one tiny little section. Select something that roughly looks the same. But ultimately for assignment 2, I will be giving you site files, so you don't have to worry about being too exact, but just, select something kind of like this. And now what you can see happens is it only shows the building footprints that are inside this green polygon. And if we go back to export, you can see that the shapefile, it has this new option here, right? It says only the 1466 selected records. So we can download that, but again, before we click, we need to set our geographical coordinates as EPSG 26.910. So always remember that. So now let's click only the 1466 selected records. And it might take a moment to think. Save file. And you can see that it has downloaded. So once your file has downloaded, let's go into our downloads folder. Let's right click it, go to properties, unblock, okay. Now your computer might not block the downloaded files. If it doesn't, that's a-okay. But what we're going to do now is we're going to right click the zip folder, extract all, extract to the same location, and now we have these different files. So I'm going to delete the Building Footprints 2009 file. And then what I'm going to do is I'm just going to drag the Building Footprints 2009, the unzipped folder, into my vector folder. So it lives right here. And you can see there's a few different kind of files in here. What is most important to us is the AutoCAD compiled shape and the AutoCAD LT shape source. So these are what we're going to open with Grasshopper with that @it plugin in order to bring them into Rhino. And then also we're going to use the records within the embedded data to extrude the buildings. So what we're going to do is we're going to open Grasshopper. So type Grasshopper into your command bar, or click the little Grasshopper button. And at this point, just make sure you have the @it plugin. So when you install a plugin, I'll probably have more than you, maybe you have more than me, but you'll see there's these little tabs at the top, and you should now see one called @it. If you don't see it and you've copied it into your Grasshopper Components folder, you can always go to File, Special Folders, Components, find the @it folder, and you might want to go into it and then see if there's anything that's blocked. So if you click Properties and it says blocked right here, you might want to download @it again, unblock it, and then reinstall it. But I hope all of you have it here. Let me know after class if you were unable to do so. Now we're going to start from a new file. I'm going to open my notes because I prepared for this class over a month ago now, so it's been a while, but I remember the gist of it, so we will be okay. Okay, Okay. A-okay. Okay. So, essentially what I'll do is I'll have Grasshopper open in the foreground. It's always kind of weird. I'm sure a lot of you, if you've used Grasshopper and you have two screens, you know the joy that is using two screens with Grasshopper. But I'm going to try to make the most of it here and sort of go half like that. If you can't see a component, please raise your hand and let me know. So the first thing we want to do is we want to navigate to our shapefile. So what we're going to do is we're going to go to params. We're going to go to primitive. And then we're going to go to file path. So params, primitive, file path. Again, if you want to know where something is, if you've placed it after the fact, you can always hold Control-Alt, click on a component, and it will show you where it's located. And again, if you miss where something goes, again, please raise your hand. But we're going to use path. We're going to right-click the input, and we're going to go to select one existing file. And then we're going to navigate to where we've saved our Building Footprints 2009 shapefile. So the one you want to select is the AutoCAD LT shape source. No, you want to select the compiled shape. That's correct. So you want to select Building Footprints 2009.shx. So then click Open, and now that input will go from orange to being gray, and that just means that you've selected the shapefile. Now the next thing we're going to do is we're going to import with at it. So we're going to go to at it, we're going to go to shape, and then we are going to go to imp at it. So import at it shape. Lots of contractions going on here. So imp at it. So the shapefile. You know what? I think we did need to. Well, we'll see if this one works. I think it might have actually been the other file we need to import. Anyways, connect your path file to the input. The WGS84, we can leave it as default false because our projection is not WGS84. It's the EPSG projection, so we can just leave that as false. And then the final thing is set Boolean true to import shapefile. So to do that, we'll grab a trusty Boolean toggle. We'll go to params, input, and then Boolean toggle. We will plug this toggle into the true false input. We'll click true. And I was wrong in my SHX. It is the shapefile. So that's fine. Let's right click on path. Go to select one existing file. And then instead of the SHX file, we're going to choose the Building Footprints AutoCAD LT shape source file. And now when we click true, it's gray, it's happy, nothing is giving us an error. So at this point, this is all you're going to have. Now you're not going to see anything because the thing with shapefiles is they have different data sources. So they have points which define vectors, but then they also have fields which define other characteristics within the shapefiles themselves. And that's why we use a special plugin like @it to access those special characteristics. So the next component we're going to use is we're going to go to @it, shape, and then data viz @it. So visualize spatial and non-spatial data of specified shapefile. So that's @it, shape, data viz @it. Now, the input is going to be our shape objects. So our imp at it s output is going to go into the s input of the data viz at it. Now, filter by feature, filter by value, get value of feature, true, false to import shapefiles. Essentially all of these, we need to essentially choose what we want to bring in. So if we look at our F output here, so features is list, let's grab a panel to see what's in here. So let's go to params, input, panel. So features output plugs into the panel. So again, trusty params, input, panel. Just a quick refresher, if it's been a while since you've used Grasshopper, you can also double click on the canvas and type panel. But essentially what we see here is these are some data that is also saved in the shapefile format, so different fields. So you can see here there's ID, orient 8, building ID, top eliv underscore m, med slope, base eliv underscore m. Now, if you want to find out what these mean, what you can do is you can go back to the trusty City of Vancouver Open Data website. And then if you go to information under building footprints, so building footprints information, click on dataset schema, and it's going to tell you what each of these means. So ID equals a unique identifier for each footprint polygon. Orientate, you know, it's kind of clever. It's like a it's like a vanity license plate. Orientation, it's the rotation from north, it looks like. And then some things that maybe we're a little bit more interested in, like the top elevation, so highest elevation of the building element in meters. Medium slope, so the slope of the roof. The base elevation, so it's the lowest elevation of the building, so that's another one we're going to be interested in, as well as the highest building element above grade. Roof type, you know, a bunch of other things. Area could be useful for some sort of project. So all these things. So look through them to see what we want. In this example, I think that I was probably most interested in, let's see what we got here. Okay, I see what I did here. So we're going to use these to filter after the fact. So the thing we want to do now is we want to plug a toggle into the true false input of the true false at the bottom, and then that's going to make this component work. So we'll go to params, input, and then Boolean toggle, plug it in here, turn it to false. And then, so, okay, I see what I did. So what I did was for this, I essentially plugged all of these features into the get value of features. So essentially what this means is that this first input here is asking for just the basic shape objects that are coming out of the shape importer. The filter by feature, which we'll try using here. I think it's a better way than I did in the past. We'll leave it blank for now. The filter by value feature we'll leave blank. But what I did was I plugged in all the features, plugged into get value of feature, and then what that does is it essentially gives us all the data that's in this file. So we get our polygon geometry, we get our polyline geometry, there's none, we get our point geometry, and then we also get our values for each polygon. So for example, if I go to params input panel, I take the values, I plug it into the panel. You can see that the index of each item here, so index equals 0, ID equals 16277777, And what this is this corresponds to some footprint here. So let's say that this outline here is ID 162777. It means its orientation would be negative 44 degrees from north. Its building ID would be this number. Its top elevation would be 80. Its base elevation would be 32. And that's how we're going to start to use this data to create a 3D city. So we'll just move forward with this. Does anyone have any questions about what this data means in here and how it relates to the geometry that we can see here? I have a mic which I can mute with a push of a button, so not only when I ask you those open questions, it gives me a chance to slurp down a lot of water, so it's good. All right, so we'll move forward with this. So essentially we have all the imported building footprints, and then we have all this data that goes with each one. So what we want to do is we want to essentially, if we're thinking about what we want to do, we are going to take our footprint. That's step one. We have our footprint there already. The next thing we're going to do is we're going to move it up to the base elevation. So we're going to take this footprint and move it up. By this case, base elevation is 32 meters. So we'll move it up 32 meters. And then the next thing we're going to do, I'll bring it over here, is that we'll take that elevation or that base which is moved up, and then we're going to look at the top elevation, and then we are going to extract it to that height there. Top elevation in this case would be 80. So that's kind of the thinking behind what we're going to do here. Now, you might want to get fancy in the future, and maybe this is a way you get those extra bonus marks for assignment 1. You could always like look at the roof angle and start to tilt the angle of the roof, but in this case I'm just going to look at how can we bring in this data quickly and extrude in 3 dimensions to sort of get a quick but accurate site model. So to grab this data, essentially what we're going to do, you can see that each of our polygon shapes is essentially brought in its own tree, or its own branch. So let's go to params, utilities, param viewer, just a quick review, and take the P output, so polygon geometry of shapefile, plug into the param viewer. So essentially what you can see is that we have a whole bunch of branches, so 1466 branches. What that means is each of these outlines is in its own branch, which means that we can sort of look in isolation. If we want to look at that another way, we can always go to params, input panel, take the polygon geometry output, plug into the panel, and you can see that we have some polyline curves here. Now, some of these curves, you can notice there's more than one curve in each group. I'm not exactly sure why that is. It could be that the curves are not joined, or maybe it's because they are open or something. But you know what I'm going to do, what did I do here? I guess I'm going to try joining them. So if you ever see something like this where it seems like you might want to join them, we can try joining them. If they join, great. If they don't, that's fine. So let's go to curve, utilities, join curves. Plug that in there. And it looks like that didn't do anything, so that's fine. So what that tells us is that in each branch there might be more than one building footprint, so that's fine. So we can just delete that. Okay, so first let's grab the base elevation. So base elevation is index 5. So in each of these branches, the index 5 item, or the 6th item, is going to be the... Oh, can you please draw full names? Perfect. Good thinking. And also, just could you, for future, just raise hand just in case I don't see it, but that I caught that one, so that's good. We can just actually delete join curves, to be honest. So what we're going to do is we're going to select the base elevation, so that's the 6th item, or index 5, in every branch. So we can go to Sets, List, List Item. The list that we want to operate on is our, I guess, at values. So the attached values, I'm assuming what it stands for. Plug it into list. And the index we want is index 5, because index 5, we can see on the side of our panel, is the base elevation. So list index equals 5, so we can, why don't we just grab a, go to params, primitive, integer. I'm going to right click on integer. I'm going to rename it to 5. So written 5, just to remind myself what is in there. And then I'm going to go to set integer, and I'll click 5 and click enter, and then commit changes. So you can see the output now is 5, and I'll plug that into the index. So now you can see that what we have here is a whole bunch of bottom elevation. So if we want to see that, we can choose a panel, input panel, and you can see we have 32.01. That's the first base elevation. If we keep scrolling through, 37.84. That's the 27th. Scroll down to 27 there, we'd see it. 37.84, and so on and so forth. So those are the base elevations of all those outlines. What I can do now is I can just group this. So I'm going to select the 5 input and the list item there. I'm going to right click, I'm going to go group. And I'm going to group this just to sort of remind myself later what this is actually doing. So I'll right click the group, so right click on the purple box there, and I will call this base elevation data, like so. The other thing I can do while I'm here is I can select all this, I can group it, I can right click the group, and I can call this shapefile importer. And then what I can do further to that, and the reason why I'm doing this is just a good habit to be in, and it also is how you're going to get full marks for the annotation portion of your assignment. You can see I do it here. I sort of label things, I group them together. You can write a note to yourself as well with a panel. So in this case, I'm just going to double click on the canvas. I'm going to type panel, and I will just put this panel in this group. I'll double click it, and I'll write something like, remember, this is going to help me to import .shp file and not .shx file. So you can do stuff like that just so you remember what's going on here, and then I can add it to the group. So we have our shapefile importer and our base elevation data. The next thing we want to do is to bring in the top elevation, but then there's also another, if we go back to the City of Vancouver open data, there's another category here that actually sounds like something that's kind of better than we want. So let's see. Yes, so the HDT_AGL, so the building element height above grade level in meters. Essentially this is top elevation minus base elevation. So this is essentially the building height. So we're going to use this building height for our extrusion height. So we won't even worry about the top elevation. We'll just use this height instead. So HGT underscore AGL. If we look in our panel here, sort of our legend of the data we're bringing in, we can see HGT AGL is number 6. So then what we can do is we can recreate this list item thing. I'll do it again just to review. So I will first grab an input. I will go params, input, and then I will go, or sorry, I'm looking in the chat. I'll go file or params, primitive, and then integer. I'll right click it. I'll write 6 just to remind myself that we're looking at the 6th. You could always do something like 6 bracket HGT underscore AGL. This is really just to remind ourselves. I'll go set integer and then 6. And then after that, what we want is a list item. So let's go to sets, list item. Six, I'll plug into the index. So again, the index is the location in each list. So the 6th index or the 7th item in a list. So I'll plug 6 into index. And the list we're going to be looking at are the attached values again. So now you can see we have a bunch of single heights coming out of the list item. And what I will do is I'll select both of these components. I'll right click outside them, go group, and then I will right click on this and go building height. So quite simple. Now, when you're this far, what I'd suggest you do is let's save. As a lot of you know, if you've used Grasshopper, things crash. So let's save this 200615 shape importer, however you want to save it. That works for me. And yours should look something like this at this point. Now simply what we want to do is we want to move up the base curves and then extrude them by the height, and then we'll convert these to meshes. So first let's move up these shapes. So let's take our polygons. So these are all the polygons I've imported. And then let's go to transform, Euclidean, move. So move an object along a vector. The geometry that we want to move are the polygons. So let's plug polygons into geometry. We can just move down these groups to sort of make things a little bit cleaner. Oh, can I ask you guys a question? Can you hear something in like the washing machine right now? Because it sounds like someone's just like, dude, oh no.
Yeah.
Okay. Yeah, a waffle. That's a good. Okay, I'll see if in the future I can prevent that, or I'll see if I can get a filter or something. Yeah, don't do your laundry. I'm talking to people on the internet. But anyways, so sorry about that. But anyways, no dogs have barked, so that's all right. It's soothing. Okay, please don't fall asleep. So anyways, you can see by default, all these buildings are moved up 1 meter, because the motion by default, or 10 meters, is 0, 0, 10. So 0, 0, 0, that's X, Y, Z. So Z is in the, it's up, down, that direction. So what we're going to do is we're going to switch out that default value for the value defined by the base elevation data. So what we want to do is we want to go to vector. We're going to go to vector, vector, and then unit Z. So that's vector, vector, unit Z. And again, if you look in the bottom left-hand corner of your Rhino viewport, you have your XYZ compass. So just a refresher, Z means up. And what we're going to do is we're going to plug our base elevation data into the factor input. So now what we get is a whole bunch of up vectors with the base elevation as their amplitude. So now when we plug those into the motion, you can see that they're all now moving to different heights. And you can see actually, even if we look in, elevation, they're starting to get this, I mean, it's the real coordinates, right? Like, so Vancouver, it sort of tilts up as it goes towards the center of the, I guess, peninsula. So that's looking good. The next thing we're going to do now is, since we have moved these up, is let's just quickly group this. So right click, group these things, label it. Let's just say moving up the footprints. And again, please, when you're doing your hand-ins for this class, and just for personal good habits, organize your grasshopper files. So move them up, and then what we're going to do is we are going to now go to Surface, Freeform, Extrude. So Extrude has two inputs, so it extrudes a curve along a vector. The base is going to be the profile curve or surface, so that's going to be our geometry that we just moved up, the footprint. So let's plug that into base. And the direction is again going to be a z vector, but it's going to have the building height as its amplitude. So let's go to vector, vector, unit z. And let's plug the building height into the factor input of unit z. And then we will plug the unit vector into the direction input. Now, voila, you have Vancouver. So that's pretty neat. I mean, as a starting point to a site model, you could do much worse. So all these buildings are accurate as far as it's based off City of Vancouver LiDAR. So like I said, we use the same data set in professional practice. We, spruce it up, use the building angles, or the building roof angles and everything. But I mean, City of Vancouver will accept this for a zoning or rezoning application. So now we have these extrusions, but let's cap them. So what we're going to do is we're going to take these extrusions, fill the little holes at the top. So we'll go to Surface, Utilities, and then Cap Holes. Take the extrusion output, plug it into BREP input. Yeah, so then what Natalie is referring to is if you go to display, you might have no preview on and then you won't see anything. Or what might happen is you have under display selected only preview. And if that's the case, if you selected cap holes, mine doesn't preview either. So maybe that's it. But what you can do, and what I always do, is go to display and then I just go shaded preview. So that's kind of the default setting. Yeah, and also the other thing too is if you're not seeing anything and you've imported in the yes, okay. So Kevin, so I'll quickly address some of the issues here. So one of the things that could happen, and it's happened to me before, is you want to double check your coordinate system. So if you go to export and export with the WGS84, it's going to export a different coordinate system. What you could try doing if that's the case, you could always try setting project to WGS84 to true. And then that might move your shapefile to the same location as the rest of your geometry if your geometry was imported with the proper EPSG coordinate system. If your geometry is showing up in different spaces, it's for sure because you accidentally chose WGS84 for one of your imports. And again, for anything else, it could be your display. But if not, if you're still having an issue, anyone, just let me know and I can take a look after class. So anyways, I've capped all the holes here. The last thing I'm going to do is, unless you were really going to go back into some of this geometry and like work on it to add detail in Rhino, it's best to convert these to meshes, because meshes are just much lighter on your system. So these are all BREPs, so boundary representations, NURBs. What we're going to do is we're going to convert them to polygon meshes. So we're going to go to Mesh, Utilities, Mesh BREP. And we're going to plug our BREP into the BREP input. And now what I'm going to do is I'm going to preview off all of this stuff. And now you can see I have my building meshes, so that's great. What I'll do now is in Rhino, I'm going to make a new layer called 3D building meshes. And then for Mesh BREP, I will right click on the output or the component there. I'll click Bake. I'll select the 3D building meshes layer. For something this big, I might want to group it. So maybe group, yes please. I'll click OK. And of course it's doing an autosave right now. But as soon as the autosave, oh, there it is. Okay. So that's great. So, I'm on wireframe view. That's why we couldn't see it. So there are all my meshes. So I'll just move the grasshopper window to the side. Also here, all they are in rendered view. So you can see that this is pretty cool. It's all the buildings in this portion of Vancouver. When I was a student, there was essentially the one City of Vancouver file floating around. Maybe it's still floating around that everyone used. Now you guys have no excuse to use that old, out-of-date file. You can all make your own City of Vancouver file quickly. So does anyone have any questions? Okay, excellent. So let's save the shape importer first. Maybe what we'll do is we'll group these last little sections here, right click it, and then call it footprint extrusion. So there we are. So save this, and this is essentially a toolbox in your toolkit, or a tool in your toolbox, I should say. So save this as the shape importer file. You will want to use this in the future. Very, very handy. So that's sort of the first thing, how to import a shape file and how to access its attached value. So like I said, you could think about how you could start to perhaps angle the roof space on this, but I'll leave that to you to figure out. All right, so what I want to do now is I want to look at importing street trees. So what I'm going to do is we're going to import their location first, and then next class we're going to populate them with actual geometry. So this is something that's like really, really interesting. The City of Vancouver Open Data has essentially a catalog of all the street trees with all their proper Latin names that you landscape architecture students have memorized. So it's a really huge and interesting data set. So let's go back to the City of Vancouver website. Let's go to catalog. And on the main page actually is street trees. So let's go there. So let's go to street trees. So if we look at the information page, scroll down to the bottom, click on dataset schema. You can see that there's like the genus name, there's the species name, there's the cultivar name. Can someone let me know what a cultivar is? Well, it's blank, so the City of Vancouver doesn't know what it means either. So that's all right. And then some other things here. So like, for example, the height, which is great. So the height range ID, the diameter. So tons and tons and tons of information. So, you know, very, very useful. So what we're going to do is we are going to go to the map. And you're going to see that there's a lot of trees here. So it's just giving you these dots. And you can see that they're sort of exported in chunks. So what we're going to do is we're going to select the polygon tool again. I'm going to zoom out, and then I'm going to roughly choose the same kind of place as we had last time. And then once the shape's closed, you can see we have all these shapefiles selected. We will go to export. Again, we will make sure to set our coordinate settings to EPSG 26910. And then we will go to shapefile and then download only the 1,636 trees. It'll take a moment to think about it, and then we'll click Save File. Oh, sorry about that. I guess my sound cut out for a moment. Is that better? Yes. Okay, perfect. So all I did there was I downloaded the street trees. You know, it's the same thing we did as last time. And then I just moved them into my vector folder. So I think it should be kind of the same thing. Let me know if you want me to re-go over anything. And then what I'm going to do is I'm just going to delete my the zipped street trees folder because we don't need it. Okay, so let's go back into Rhino. Now, like I said, what I'm going to do is I'm sort of breaking this up into two parts because next class, if I look at the syllabus, we're going to be downloading a plugin called Elephant. And essentially what Elephant does is it allows you to use blocks. And in trees, that's really you know, of importance because essentially what that allows us to do is to model one tree and then you know, array it all across to all these sort of placeholders we make this class. And then if we want to update that tree, we can just edit the block and then all the trees in the entire site will update. So it's a really, really good workflow. You can also see how it's a little foreshadowing of the future when we're using blocks in towers and then finally blocks in rendering with Unreal. So it all ties together. But for right now, we're just going to import trees and we're going to represent them with lines. So that's sort of what we're going to do right now. So this is just my little notes there, and I have enough to work off. So what we're going to do is we are again going to go to go to primitive. We're going to go to file path. I'm going to right click the file path, go select one existing file, go to your streettrees.shp file, so street trees, and then street trees shape source. Open. So streettrees.shp. And now we're going to go back to the @it plugin. We'll go to the shape import. We'll go to imp at it, import and store shapes, put on the canvas. We'll plug our file path into the shape file path input. We'll leave the project to WGS84 blank, and then true or false. We'll grab a Boolean switch. So let's go to params, input, Boolean toggle. Plug that into true or false. Double click it. And now you can see nothing's really showing up here, but we have some shapes coming out as well as the features. So like we did last time, a little bit of review, let's grab a panel. So I'm going to do this the kind of the quick way. I'll double click on the canvas and type panel. And I'll take the features and plug it into the panel. So this lets us see what we have here. So you can see we have all these different things here. And why don't we look at the data that we have in the city of Vancouver. So let's look and see what we have here. Let's go back to street trees, information, schema. Now, in the future, you will have enough knowledge, particularly you landscape architecture students, to take the genus name, the species name, and to assign blocks by these species names and genus names. I'll go through this as kind of a extra sort of at the end of this section. So we're not going to do this right now. We're going to essentially just work with height right now. So we're just going to work with height, and then also we will work with diameter as well next class. But for this class, we're just going to work with height. So forgive me, I'm just kind of a dumb architect who doesn't know anything about plants. And I know, like, I work closely with a landscape architect right now, and I always show him renderings I did, and I always feel kind of embarrassed when he just like shakes his head like, no, that's not how plants work in the renders. So but we're just going to deal with the heights and then also the positioning of the plants for this class, and we'll sort of go back into the genus and everything else like that later in the course when we have a little bit more knowledge. So height range ID, 0 to 10 for every 10 feet. So example, 0 equals 0 to 10 feet, 1 equals 1 to 20 feet, 2 equals 20 to 30 feet, and 10 equals 100 plus feet. What we're going to do is, I think that we'll have to translate this into something actionable. So I think what we're going to do is we're just going to say, we're going to take the value, so 0, and we're going to multiply it by 10. And the reason why we can do that is we just say 0 equals 0 times 10, 0 feet. Maybe that doesn't work if we think about it, because that's a lot of trees that will have no height. So I'm just thinking about the algorithm here. Then maybe what we can do is we can go 0 equals 0 times 10 plus 10, and that gives us the feet. So for example, if this is the legend right here, so 0 to 10 for every 10 feet. If we get a value of, let's say, 0 coming out of Grasshopper, we will say, okay, that means this tree is between 0 and 10 feet. So what we're going to do is we're going to convert that 0 to 0 times 10, and then plus 10, which of course goes to 0 plus 10 equals 10 feet. The next one would be 1. So if we get a 1 out of the height range ID value, that would equal 1 times 10 plus 10 which would go to, of course, 10 plus 10, and that would equal 20. And 20 is within that height range. And likewise, 2, so it's 2 times 10 equals 20, plus 10 equals 30. And then 10 times 10 would be, I guess, 110 feet. But still, this sort of gives us a good approximation of the height of these trees. So that's the little formula we're going to use to convert this data. So it's good to refer back to the City of Vancouver Open Data to figure out how you're going to, format this data and work with the data. So that being said, we have all these shapes that come out. Let's convert them into something usable. So we'll go to @it, we'll go to shape, and then we'll go to data viz @it. So visualize spatial and non-spatial data of specified shape. The shape output from our imp @it will plug into the shape input. The filter by feature, we'll just leave blank for now. The get filter by feature value, we'll leave blank. The get value of feature, we'll just plug in all of these again. So we're saying get the values of all of these features. So sort of what we did last time. And then the true or false, we might just want to use the same Boolean toggle here. So let's just grab the output of this Boolean toggle and plug it into true or false. So now you can see, kind of interesting, what we get here is we get a bunch of dots. So the point, we get a point value. So this essentially is giving us the location of the tree. And what we're going to do now is we are going to extrude a little line from each of these dots, and we're going to do this to represent the height of the tree. Now, right now we don't have a ground plane, and I don't believe that these trees have elevational data. Yeah, so they don't have elevational data, but that's okay, because what we're going to do next class is we're going to work with these little, the beginnings of the trees we import, and then we're going to intersect them with the ground we import in. So what we're going to do now is simply we're going to grab the, where is that? It was the height range, so number 14. So in the attached values, let's select number 14. So let's go to sets, list item, attached values, plug into list. Index will be number 14. So let's go to params. We can go to primitive, integer. I'll right click it and call it 14, or let's also put height range to sort of remind us. I'll go to set integer, I'll click 14. These are going to give us a bunch of height ranges. Let's grab a panel. So I just went params input panel. The panel gives us all these, 1s, 2s, 3s, 7s, etc. Remember, we're going to use this format here. So the output times 10 plus 10. So what we're going to do is we're going to take this output and we're going to use a formula. So what we can do here is we can go to maths, let's go to script, and then let's go to evaluate. So that's maths, script, evaluate. Let's plug our item output into variable x. Let's rename this input to just x, because if you don't rename it, then you'll have to type variable x, and that's a lot of typing. We can also zoom in, and you can click the little minus node right here to get rid of the extra input. We just need one input, the output there. And we will double click the evaluate to bring up the expression editor. And if you remember the little expression that we had thought of, it's the output, so x, because x is the input, times 10, and then plus 10. And then if we think back to our bed mass, so brackets, exponents, division, multiplication, addition, subtraction, don't need brackets. So we're all good. Click OK. And now our result from 1, if everything went right, the result of 1 should be 20. So let's see. Let's go to, we can double click on the canvas, type panel, take the result, plug in, so 1 equals 20. So that's great. Now what we're going to do is we are going to take these results and use them to draw a line from the point that we get out of the data viz at it component. And these are going to be placeholders for our trees, and next class we'll move them up to the surface once we import the surface. So now what we want to do is we want to go to curve, primitive, line SDL. So the line start point is going to be our point values that come out of the data viz at it. So point values will go into start. Direction by default is Z, so 0, 0, 1. So again, that means x equals 0, y equals 0, z, aka straight up, equals 1. So it's direction straight up. And the length will be the result of our expression here. And now you can see we have all these trees. Now, oh, the expression, sure. So the expression is x times 10 plus 10. And your input is x. Now, there might be something here that you notice is a little bit peculiar. Oh. And essentially, what is that these trees are taller than all the surrounding buildings. And while Vancouver might have some nice old growth trees in it, they're not really, you know, this tall. So let's go back and see what's going on. Oh, remove the y variable. So the way you remove it is you zoom in to the component and click the little negative icon next to the y. You also need to rename this variable to be x. So by default, it's going to be variable x, and then it won't give you a result. So what you need to do is you need to rename it. So just right click on variable x and rename it to be x. And then you're going to see the lines here. So like I said, these lines are way too tall. If we look back at the City of Vancouver street trees entry, you can see height range ID, so 0 to 10 for every 10 feet. If you think about it, our units are in meters, right? So essentially that's why they're way too tall, because we're drawing them in meters when they're giving it to us in feet. So what we need to do is we need to convert the meters to feet. To do that, we can simply divide by approximately, I think it's 3.3, or something a little bit more exact. We can just go feet to meters in Google equals 0.3048 meters. So let's just copy that 0.3048. I'll copy it into the chat. And now let's go into our expression editor and sort of do an addendum to this. So let's put brackets around our entire definition like so. So add brackets around the x times 10 plus 10, and then put times, so the little star, and then copy in the 0.3048. And that will convert our trees to be in meters. Click OK. And now you can see our line SDL is much more reasonable. So those are the actual heights of the trees. Now, like I said, we will have to wait till we import the LiDAR data. So that'll be next class. to bring these trees up to the proper height. So what we'll do is we'll simply take these lines, bring them up to the proper height, and then after that we will populate them with blocks. But for right now, what you can do is I'll leave it to you to organize this a little bit better. So group things, label them like you did above right here. So you can do that after class or whenever. Just because I want to get to one more thing in the last few remaining minutes. So what I will do at this point is I will actually just leave this for now. So save this file. So maybe I'm going to save this in the same document. Maybe I'll group it all and just call it trees, just so I remember. But we're going to come back to this one. But like I said, I just wanted to group the trees import in the same kind of lecture as all the import. So any questions about importing trees? Or half importing them, really? Okay, so that's great. So I'm going to close Grasshopper. What we're going to do now is make sure to save your Rhino file at this point. What I'm going to do is I'm going to start organizing my layers here a little bit more. So what I'm going to do is I'm going to make a new layer. I'm going to call it 2D info. And I'm just going to drag all my 2D info into this. So everything right now except for the 3D building meshes, all pulled into 2D info. And then also I'll make a new layer called 3D info. And I'll drag my 3D building meshes into there. And that'll just make it easier when we come back to this next class. So the final thing I want to do is import in the ECW data. ECW data is the ortho images, or the sort of Google Street View type satellite images. And the reason why you want to bring those in is that you look at the block information that the city of Vancouver gives us, and you can see that these blocks, they're legal blocks, right? Like they don't actually describe accurately the shape of the sidewalks and everything. So we are going to want to import in the ECW or ortho imagery to be able to clean up these blocks, to trace them. So what we're going to do is we're going to go to the City of Vancouver site again. Click on Catalog. And then what we're going to do is we're going to click on the side theme. We will click on Geography and Imagery. Now, right at the top of that, you're going to see Ortho Photo Imagery. And essentially what's going to happen is we are going to import some ECW files. So, here, I just want to check something in my notes, sorry. Okay, so what we're going to do is we're going to go to Map. And I'm just going to do this for one file right now. Actually, I'll do it for a couple. So what I'm going to do is I'm going to click on, in the map, I'm going to click on this block right here. So essentially I'm going to choose the files I want to grab ortho imagery for. So I'm going to click this one here that has Cardero and Davie and English Bay. And then I'm going to click on the ECW URL. And I'm going to save it. So it's a little bit different. We're not going to the export anymore. What we're doing is we're clicking on the map and we're just exporting that way. So I'm going to download that section. I'm going to download this section here that's right below. Again, clicking on ECW, save file. And then maybe I'll download this one that has the Granville Bridge as well. Now you could download more. And now we can look in the folder. What we can do is we can go to extract all. So BC 15 and 10, I'm just going to delete it after I extract it. And then I'm going to extract all again. I will move that into the raster folder, the one I just extracted. So moving those all into the raster. And then the final one that I download 4, did I? No, I didn't. So I'm just deleting the ones that I've already used, and I'm extracting the ones I haven't. For some reason, my computer, it's like not, when I delete something, it's not deleting right away. It's strange, you're extracting right away. I don't know why, I'm having to refresh it, so I'll have to look that up. And I'll put this into raster. Regardless, what you should have at this point is a few different folders in your raster folder. And you know what? I think looking through the steps I have left, I'm going to leave it there for this class. Like I said, I thought we might need an extra class for this section, and I think we will. So I'm glad I sort of planned that out. But I'm going to leave it for there because we're going to dive into a lot with 1 minute left, so it's not really worth it. So I will say for next class, though, please download it and install a few things. So GeoViewer, which is the thing the freeware we installed at the beginning of this class, make sure it's up and running. Cloud Compare, which you can find right here. And then Elephant, which is a plugin for Grasshopper. So are there any questions before class breaks? Yeah, Colin.
Yeah, my script for the trees is looking really good. Like there's no error codes, but the tree, like the green dots aren't showing up on my, like in my Rhino window. I've reset the file and made sure it's unblocked and done all the like classic things. Can you think of any reasons why I might be not seeing my tree points?
But you're saying the lines are showing up?
No, I'm saying I don't have any errors in my script. Like it, and I can see in my panels things show up and it looks pretty good. Should I just maybe try to restart?
Yeah, you can do that. And also, maybe what I can do, and again, this is kind of, I mean, the what we can do as a class for this, but also for, you know, just sort of help sessions in general or one-on-ones and everything. If you guys want to download TeamViewer, so just look up TeamViewer, and essentially it's a remote control. I use it all the time at work to help some of the people in my office if they run into issues. We could use that to sort of solve problems either in the one-on-one kind of desk crit setting or also for questions like this if we're trying to troubleshoot. So for now, I'd say install this. If you want to stick around for a couple minutes, then I can take a look. But that's probably the way to do that. So does anyone have any other questions? Okay, so when will you generally upload the lectures? I will get them going right away. The one caveat to that is that it does take a while to process, like, 2.5 hours of recorded lecture. Usually takes, I think, about an hour and a half to render it out. And then at that point, I have to upload it to YouTube. So I'll for sure start the rendering as soon as the lecture is done. That being said, I usually don't go to bed at, like 10:30 or whatever, but sometimes if I'm just busy or whatever, I don't get a chance to upload it to YouTube. So I'll say at max 24 hours, 80% of the time it'll be up first thing the next morning. Okay, awesome. Well, I'm going to stick around for a few minutes. I'll take a look at, I think it was Colin's screen once you get TeamViewer installed. I'm just going to grab a glass of water for those who want to stick around, so just give me a couple minutes till I come back online. And for everyone else, thank you so much for the first lecture. Of course, there's still going to be some kinks to iron out as we all sort of navigate the online lecture format, but I think that this course is going to be really exciting, and I think it'll be a lot of fun and very informative. So I look forward to seeing you all on Wednesday. Okay, bye.